stream. So, we left off. It's been a while. We had our test on Monday. Yesterday, Fubar Day, leave me alone, I gotta work. So, right after example 3, before we get to example 4, in the book, or in your packet of notes, I want to go one slide past that. And let's get ourselves back in math mode. Okay, let's get ourselves back in math mode. I want you to find fog, goth, fog, we'll do fog of 1, goth of 1. There we go. Okay. Just want to get us back in math mode. It's not a daily quiz. You can work together, but we need to get back in math mode. It's been a couple days. Take it out of the wrapper.
I know not to put aluminum foil in the microwave. You ever see the Bush March just go?
One of our former foreign exchange students did, and we gave her all the crap in the world.
That's what you have.
Yeah. F of G, G of F. Well, it's aluminum foil, so it has electrical arcs. No, it was only in there a couple of seconds. It started sparking, and she freaked out and, turned it off. But something about foreign exchange students, they absolutely love Pop-Tarts. She'd come in here for one every day. Probably because it's trash food that I don't think is even allowed in other countries. It's not actually food. But it's so good.
Toss enough sugar on it. Anything's food.
Yep.
Does that mean I can eat
Rice and
glass
deer
if I toss sugar on it? Tomorrow?
Yeah.
Will we be into the research?
Yes.
I didn't have any notes for myself. I didn't know if we were.
No. Up.
What? Oh.
Because I haven't handed them out yet. Once I've handed them out, they go in that bin.
Well, last time I didn't have a chapter 1 notes, so that was fine.
Yeah.
Are you done?
Stop it. During lunch, go for it. Right now, no.
I was thinking of
Okay. Sounds like we're there. F of a thing, the purpose of it is to take square root of thing minus 2. G of a thing, on the other hand, is 3x. Its purpose is to take 3 times a thing. In both cases, that's it. I can't really simplify them at all. So it's just square root of 3x minus 2 and 3 square root of x minus 2. Fog of 1. Shove 1 in here. 3 by 1 is 3. 3 minus 2 is 1. Square root of 1 is 1. Goff of 1. Did anyone remember that as you're doing compositions, part of doing the composition is to state the restrictions to the domain. Set the radicand equal to 0 and solve. 2/3 and onward is all that's allowed in FOG. So f of g of 1, perfectly legal. But because Goff, g of f, has a restriction to its domain of 2 to infinity, when I ask what is g of f of 1, I just say no. Can't do it. Plug it in. Because, as the Council of Ladies said, you end up with imaginary numbers. Okay? So, just getting us back in math mode. Making sure we remember how compositions work, because told you as we prepare you for trig and calc, you're going to start seeing more algebraic proof, more manipulation, more I'm doing the thing just because I can. And it's not just because I can. We're laying the foundation for later algebraic proofs. Now we're going to decompose. So we're going to work backwards. It's kind of like I have this. You go to someone else's house. You're looking at what's for dinner. They got a big pot on the stove and there's just stuff in it and you're trying to figure out what you're going to be eating. I don't know what this is. I've never seen this before. You try to figure out what went in there. Is this safe for me to eat? Or am I about to puke? Okay. I'm going to decompose my functions. I have to state what is f of x and what was g of x, such that I put this in here and end up with h of x. The safest way to do that is to identify what's the ugliest part of it. What's the most annoying part? The radical. So that will be my last stop on the train. That'll be my f of x. Because now, what do I put in there to create h of x? X cubed minus 4. Okay. I put this right here for x. I'm good. Does anyone see another way you can do it? There's wrong answers, but there's also infinite number of right answers. What's another way I could have done it? Okay. If I had said f of x was the square root of x minus 4, now what do I plug in? Right? Replace x with x cubed, and I end up there. So when you look at the solutions for this section, every one of them is going to say sample answer. Student answers may vary. And that's because really there are an infinite number of ways I could have done this. I had mentioned to several students yesterday, or to the class, you know who you are. If you're gonna cheat, don't cheat stupid. I can tell who is just writing down the answers, who is just copying the solutions. If you think you're sneaky about it, you're not, because they word it and phrase it in a certain way. I guarantee you the next time I check the notebooks, someone is going to have Student answers may vary, written down in their homework. If you're gonna cheat, don't cheat. Stupid. Okay? It happens every year. What about the other one? We came up with like 6 ways to do this last hour. What do you think?
X minus 2 and X cubed minus 2. Or square root of X minus 2.
Yeah, part B. We're on to B now. But yeah, you could keep going with A. I want to move on to B here. What are ways that you can break B apart? I can factor it, right? So take out a GCF. Can I keep going? A and C are perfect squares.
X plus 5.
Okay. Can you use that knowledge that it's been broken into parts to find a F and a G?
2x squared and then x plus 5.
F of x is 2x squared. I will shove in there a x plus 5. That works. More. Okay, this is one way it was broken up. Here's another way it's broken up.
We could have 2x and then x plus 5 squared.
There you go. F of x is 2x. G of x is that whole quadratic. I can either leave it as x plus 5, the quantity squared, or write out the quadratic. That works. Anyone else? You'll notice there's a constant at the end of stuff.
Can you just do x plus 50?
Uh-huh. F of x is x plus 50. G of x is 2x squared plus 20x. Okay? So there's a bunch of different ways you could decompose something. I could keep going. You could just do and undo the same operation for anything. You can get as facetious as you want with it. But the idea is don't overthink it. Also, don't underthink it. Read the directions. Neither function may be the identity. Meaning, I cannot say f of x is x, g of x is this stuff. That's like when I ask, what else is this divisible by, and you get that kid who says 1. Okay, it doesn't change anything. So you're not allowed to do that. You can't do the identity. But you can get awful close to the identity. Keep it as simple as possible. Okay? So, I do some, you do some. How can you break those up? You might not do it the same as your neighbor, but I want you to talk to your neighbor and see that, does yours work? Does mine work? Do that whole attendance thing, huh? Mhm. Mhm. Yeah, we're down a good ways. 8 gone for band and choir. Okay. Sometimes they're obvious, like our original A was, where you just put the ugly part at the end. Sometimes, like our part B, well, maybe break it apart, factor it, do something with it, and then use those break apart stages as your F and G. Pretty straightforward. Is anyone still struggling with one? Round one. Someone give me one way. Oh, yeah. Okay, that works. What else? Anyone do it a different way? You recognize the perfect square trinomial? Okay. Say if you recognize that this is x minus 1, the quantity squared, you can be real facetious about it. I've had kids say this. F of x is the square root of x. G of x is x minus 1, the quantity fourth. It works, right? It's needlessly complicated, though. Believe me, there's a bunch of ways that we could have done this. These are probably the two safest ones. I'm betting 4B, most of us got the same thing. Right? Okay, take the ugly part, leave that for f of x at the end. There is one problem. There's a little section of like 4 or 6 problems in this in 1/6 assignment, and I'll always assign at least one of them. They're tough. You have to find out, how do you undo each part to get where you're at? What happens when it got tougher? What happens when I said h of x was 3x over x squared plus 4 minus square root of x? You would really, really have to puzzle out, okay, if I put this in here, how do I undo the parts I don't want to make it minus 4? If I put something in here, how do I undo it so it just comes out as square root of x instead of square root of x minus 5? I'll throw one of those in the assignment just to see who can come up with the answer. It's tough. Like, I ain't gonna lie, it's tough. See if you can puzzle that out without the solutions. Every year you got the one kid who figures it out the hard way. You got the one kid who figures it out the easy way. So, on to the last part. Said we're going to finish 1.6, move into 1.7. We're getting a new book next year. I didn't want to change the notes. Cross this out. This is dumb. Doing a composition of functions for that particular example, they're just linear functions. It's easier to just write a linear equation. Like, it wasn't necessary. But I do want to talk about this one because this happens in real life. Every year I save money, like legitimately save my money with this concept. Okay. You got a store, 15% discount to college kids if you're going to buy a laptop. They also have $100 off coupon. Coupon. It's a Ron White thing. He's a horribly irreverent person and not a good human being, but he had a good bit about coupons. So, how do I write those as functions? If I say the coupon function, the price is the coupon first. The price is whatever, and I'm going to take $100 off of it. What about the discount function? Okay, now, well, it says 15%. Why are you saying 0.85?
Because 15 minus 100 is
Okay, it's 15% off of the price, means I am paying 85% of the price. Okay. Find the functions to model the data, find Call of Duty, and run DOC. Compose. If I find C of D, C purpose is to take a thing minus 100. C is, where to go? X minus 100. D of X is 0.85X. D's purpose is to take 0.85 times a thing. So I do my two compositions and get distribute which one's a better deal? How do you know? You don't even know the price. Exactly. I don't need to know the price. I need to know that in both cases, I'm going to pay 85% of the price and then knock off $100 or knock off $85.
85% of what?
Okay. So they ask which one's a better deal and why. Well, if I do C of D, apply discount first, it gets me a better deal. And I would like you to put those words in some sort of big honking neon holy crap sign. Apply the discount first. Years and years ago, as we were teaching this, there's a girl in my class, it was Algebra 2 when we first saw this. And after saying that, she lets out this big gasp and, that's why. Like, you okay over there? Who here works now or has worked in food service? Waiters and waitresses, hostesses, bartenders. Okay. What happens when someone says, well, I have my student ID, 10% off, but I also have this coupon for $20 off my next meal?
Supposed to do the 20% first. Yeah, if you can do both, then you're supposed to do the
But you're supposed to
track,
do it, they
just the
tell
one
you
where
to
it
do it a
takes off
certain order.
a certain amount first.
That's exactly it. She worked at Applebee's, and they were specifically instructed, right here in town, they were specifically instructed as employees to always apply the coupon first. Or sorry, to always apply the discount first. Words. Bad. Always apply the coupon first. There we go. They told all of their employees to do the coupon first. Discount first. Why is this so hard? Words are hard. They told them to do this. There you go. Coupon first. Because if I do the coupon first, then my total amount that I'm discounting is less. They told them specifically to ring this up with do the coupon first. Now let's say this isn't buying a computer. Let's say this is your meal at Applebee's. 15% off during the month of February for any couples. And there's also $100 off your bill if it was like over 500. Maybe it's a big group of you. I don't know. What happens if you go in there with a like $30 tab? It's not a big deal, right? You go in there with a $500 tab, it starts becoming a deal. You go in there with a $1,000 tab, maybe you rent the back room and there's a whole bunch of you. Okay? Most people aren't going to pay attention to, they did the coupon first and then the discount only cost me 85 cents. Imagine that they're doing that to 300,000 people today, nationwide. And they do that every day for a year. How much money is that? Okay, so that's why they have this policy. Last hour, I was talking about this specific thing. I had two kids over here, both go, oh, that's why. They both work at Subway. And the way that you ring it up, it forces you, as you ring it up in the register, you do the total, you do the coupon, you get the total, then you're allowed to put in a discount. It is programmed that way. Specifically so, you're always hosing the customer over that extra couple of cents, that extra couple of dollars, and you don't think it's a big deal when you're like, well, it's 15 cents, big whoop. What happens when they do 15 cents to 1 million people this week? That much more money in their pocket instead of the customers. The reason I say you need to have this and say discount first is because every year, at least before I found out the owner was a fascist and stopped going there, I would go to Menards for do our big summer project. We'd always budget for a big summer project, like $3,000, $5,000 worth of stuff we do to the house, we do outside, landscaping, all that business. And they've always got their like 11% thing that makes people feel like they're saving money, but they've been doing that for like 15 years now. Okay. And then you have the rebates, and then you have the coupons. I always have them ring it up. Discount first. They finish ringing it up. And then I say, oh, wait, I also have this. I force them to do the discount first. I'm the math teacher. I'm running the numbers in my head. And as I'm in the checkout line, that just saved me $120. I'm a teacher, y'all. Whether we go to Applebee's or Culver's for our Friday no one cooks dinner is a family conversation because that extra $20 matters. It really does, like for our family. So this will save you money. I go to a restaurant and I happen to have a discount and I happen to have a coupon. I force them to do the discount first. Then the waitress comes back and then I say, oh, wait, I also have this. And you say, well, that's mean. You're just making life worse for the waitress. Then I put it in their tip. Give the money to the employee, not the company. Okay? This legit happens. Always do the discount first. Can you write two functions? Can you compose them? And in this case, I don't know. Does the order matter or not? Okay, last hour was really overthinking this. Your two functions will be meals in terms of the price and your tip total in terms of the price. Okay? So your two functions are the cost of the meals and then your cost with the tip. Okay, don't overthink it. The cost of the meal is X. How many of those do I have? I'm paying what kind of tip? So what do I do to the cost of the meal? Aren't you adding that on?
1.18.
1.18. Okay, gotta go the other way. Right? 18% tip plus 100% of what you owed. 118% total. Okay, so my two compositions are m of t of x. If I plug this right here, I get 3 times 1.8 or 3.54x. M of t. That's tip first. Everyone says, I'm going to tip 18%. Then you say, well, we have 3 of those. Versus, I say, I have 3 of these meals, maybe all together on the same ticket, and then 18% tip of the ticket. But it's going to be the same thing. Okay. Why did the order not matter this time, but it mattered last time?
Because it would be 1.18 times 3x or 3x times 1.18.
Because it's the total.
Okay, something with the subtraction.
It's because, like, either way, like, there's no given numbers. It's
Well, there weren't last time either.
multiplication. It's basic.
They just switch places.
Put those two together. This is multiplication. Multiplication's commutative. Both of my operations were multiplication. So the order that I multiply in doesn't matter. Multiplication's commutative. Go to the last problem. There was multiplication and subtraction, or add a negative. Multiplication and addition are not commutative with each other. So when the order mattered, it was because they weren't commutative. Commutative literally means order doesn't matter. In this case, multiplication's commutative, order doesn't matter. I can do whichever one I want. But in the previous one, I wanted to do the multiplication first because that's the order of operations. Multiplication comes before addition. Okay? And then you'll get the person who, they don't know why this works, they just know discount first. So you'll get someone come up to, some poor sap at the register and say, no, you have to do this first. And they're both discounts. And they're like, it literally doesn't matter. No, do this first. So the difference between knowing why the math works and just remembering do discount first. So end of 1.6, straight into 1.7. We had to know all this composition stuff before we do inverses because you're going to use compositions again with inverses. Inverse relation, inverse function, y'all tell me, what's the difference? Without even the word inverse. What's the difference between a relation and a function?
Relation is linear, maybe? It's like a...
A relation. That is purely a relation. The sibling relation. I grab Claire, I throw her in the sibling machine. It spits out more than one sibling, correct? Who's the other one that's always in your dad's room then? Oh, okay. I always see two younger ones in there, so okay, I thought you had more. All right, that completely ruins my example. A function is one-to-one, okay? Every input has one output,
That's what I meant.
okay? Not necessarily linear. If I plug a -2 into x squared, I get a 4. If I plug a 2 into x squared, I also get a 4. They were the same thing, but both the -2 and the 2 did one thing. So it was fine. Okay? An inverse relation, instead of map my domain to my range, I swap it and say my range is the domain now to my domain. That's an inverse. And it's not always going to be a function. A function is when I map every element of the range to one element of the range maps to exactly one element of the domain. Remember functions pass the vertical line test? If I press the 3 button, it only hits the graph once. So that means it's a function. I press 3, 3 only does one thing. An inverse function is I swap my domain and range, and it still only does one thing. Okay, the example that you have right here on the first slide is the classic example of why we have to have square root functions that cut off part of their range. See, x squared, quadratic, parabola, passes the vertical line test. But as soon as I swap my domain and range, okay, this point that was back here at -3, 1 swaps with 1, -3. Or sorry, the other way around. -1, 3 become -3, 1. I swap all of my x's and y's, and now all of a sudden that pink one, that doesn't pass the vertical line test. So this is only an inverse relation, not a function. And the way I figure that out, fairly simple. If a function passes a vertical line test, then an inverse function will pass a horizontal line test. Okay? Think about that. If I was looking at that orange parabola and I did this, it doesn't pass the horizontal line test. So when I swap my x's and y's, horizontal becomes vertical, my relation will not pass a vertical line test. Okay? Horizontal becomes vertical, in becomes out. So, if I want to know if something's even going to have an inverse, whether I should do the work at all, I'm just going to do the horizontal line test. These are both functions. Both of these are functions. They work. I'm asking if their inverse is a function. So, sometimes you just know what the graph looks like. I hope we know what the first graph looks like. What does it look like?
One to the left is the vertex.
Over, or wait, no.
Oh, yeah.
Okay. Will that pass a horizontal line test? No. So, determine whether the inverse function exists. No. That's it. That's your answer. It won't pass a horizontal line test. So no, there is no inverse function. There's an inverse relation, but not an inverse function. Cubic. Cubics can look like this. But cubics can also look like this. One of those passes a horizontal line test, the other doesn't. I don't know which this is. So what should I do? Dump it in your calculator. Look at it. Throw that into Y1, hit graph. Will it pass a horizontal line test? I don't know. Cubics have different types. Let's go.
Pass the test.
Okay, it does look like the first one. So it will pass the horizontal line test. I'll just say yes. The reason we're doing this is step 1 to finding an inverse is to run the horizontal line test and tell me whether I should even be doing the work. So, 1A and 1B. If you know what it looks like, cool. Just answer the question. If you don't know what it looks like, better be putting it in your calculator and double checking. Horizontal line test. Dump that into your calculator and determine, yes or no, will it pass a horizontal line test? If it does pass, that means its inverse function exists. If it doesn't pass,
Like if you go to the table, just keep getting closer and closer. But it won't actually Oh yeah, what if there's 0 points at somewhere?
that just means there's a gap in the range.
So it's
Remember, we can have vertical and horizontal asymptotes. We can have holes. They're still functions. It's just they're not continuous functions. Okay, I'm betting 1B we're all good. It's parabola. Parabola will fail the horizontal line test, so that's a big old no. Contestant 2, I suppose contestant 1. Looky like this. Okay. Now, we start getting into that argument, right? It looks like it's a horizontal line just under 0. This is the window stretched out to 30. If I think it's not going to pass the horizontal line test, how about I go put a horizontal line at 0? If I try to calculate the intersection, it tells me no. I can't divide and divide and divide and divide and divide and divide and somehow end up at 0. It'll be real close to 0. If I clear, zoom, in, oh yeah, I'm on a PC, so I can't do that. All right, this is going to take forever. If I would zoom all the way over here and zoom in and zoom in and zoom in and zoom in all the way in, what you would see is there's still a curve to it. Okay? It's just minuscule. It's thousandths of a unit. It's itty bitty, but there is still a curve to it. So it would not, or it would, pass a horizontal line test because it's only hitting it once, right there. This is on the other side of 0. They're never going to overlap. That's what I'm worried about. So, that one's a yes. That one will pass a horizontal line test. Its inverse is a function. Okay, we want to do that because to find an inverse, check out your steps. If I'm swapping my domain and range, first, I undo the horizontal line test to determine should I even do it. I don't want to go through all the work if the inverse function doesn't exist. I could have just said no. Part 2. Y'all remember, if I have f of x equals the rule which gets me a y, then I can replace f of x with y. The rule has x stuff in it. I'm then going to swap my x and y. And then I'm going to get the y part by itself. And I'm going to switch my notation. Y'all remember inverse notation? Okay. I tell all my Algebra 2 classes this. About half of you heard this before. That notation has bothered me for over 20 years, since the first time I saw it. Why might that notation be confusing?
Is it because it's like a variable?
Okay, I'm running into that with my freshmen right now in Algebra Half, trying to do function notation. They think it's f times x. because I just spent a semester drilling into their heads that when two things are smashed up against each other, like rabbits and hormonal teenagers, they multiply. So now you have f smashed up against x, and they think it's f times x. Well, if it's f times x, what does a -1 exponent mean?
1 over
Reciprocal. Flip it. But it doesn't, because f is not a variable. F is the name of the function. When I put that -1 exponent on the f, the name of the function, it means inverse. Not reciprocal, inverse. These foreigners, they just have no respect, nothing.
Okay, your turn to ring twice really loudly and end up.
You started playing song.
Yeah, it was you guys.
I forget to turn mine off sometimes. In first hour, it'll start screaming at me. So, like y'all seen the first the Minions movies? The first one, Despicable Me, where she goes and she gets the giant unicorn or whatever. It's so fluffy. That's my notification for my wife texting me. So I'm just in the middle of jabbing up here, and it's so fluffy. Yeah. She likes fuzzy things. I have to tell her over and over and over, we can't have another dog. So, if I'm going to make a inverse, step one, I'm going to do B first. Step one, I'm going to replace f of x with a y. F of x is not y. It is equivalent to a thing with y. It's not just a fancy y. But I can replace it. And then I swap my x's and y's. Okay, go and get y by itself. Square both sides. Get y by itself. Add 4. Swap over to the proper notation. Inverse function of x is x squared plus 4. Now it asks me to find its domain. You got to be careful here. Inverse function of x is x squared plus 4. That's a parabola. Parabolas should be all real numbers. This does not have a domain of all real numbers. Because you got to remember, when you swapped x and y, you were swapping the domain and the range of the original. What's the domain of the original? Where am I allowed to start?
greater than 4, greater than or equal to.
What happens when I put in a 4?
You get 0.
So my range is 0 to infinity. That means when I swap my domain and range, even though this looks like it's all real numbers, the domain of the new guy is 0 to infinity.
That's the range.
At least they're not doing the freshman thing. Always got that kid. So yes, this is the domain. Just make a note to yourself. Remember, just because this looks like it has a domain of all real numbers, you have to go back to the original and say what is the range of the original that has to match the domain of the inverse. That's what swapping x's and y's is you're swapping domain and range. Okay. Now, especially if we have the Council of Ladies right there in the middle of the room, I dare you. This problem got me in trouble a few years ago. I had to buy lunch for an entire class because we were reviewing this problem in my applied math, like kids who can't go into Algebra 2. boning up on our algebra skills so we can go into Algebra 2 so we can go to college. My applied math class, I had a problem like this. And they said that was tough. And I showed them the trick and they're like, oh, okay. Not a big deal. Seriously, that was really tough. You shouldn't put that on a daily quiz. I said, it's not that hard. You've been doing it for years. And they made a bet with me that if my PreCalc couldn't solve it, that I would have to buy them lunch. And I put this exact problem up on the board, and there were only 2 kids in my PreCalc class who could find its inverse. Turn this to y, swap x and y, prove me wrong. Do you remember how to get y by itself now? Pop-Tart to the winner.
Isn't it you just have to do that x minus 1 multiplier?
I don't know. Figure it out. And that's disingenuous. I do know. But how do you get y by itself? Prove me wrong. Renew my faith, young ones.
I see how it's
And most of us got that first step down, and then we look at the result and go, huh, do you remember? Everyone confidently starts writing. Ha! Get wrecked, math teacher. Oh.
After what, this?
Oh, wait.
And then divided by y. Divided by y on the side.
Very one of the ones.
Yeah.
Anyone? You end up like a Yorkie chasing your tail. Right? Oh, that's fine. I'll just divide by x. Oh. Well, that's fine. I'll just multiply by... Oh. Well, then I'll just subtract by... Oh.
Do you have to keep going?
No. It's one step.
It's one step?
one step.
I
And
definitely should know. 'Cause
it starts with an F.
Okay, now that we have that, we got this.
Ends with an actor. Yes. Okay, now that we're all stuck. Yes. You have to factor. Once you see it, it's not difficult. Okay, most of us are already, okay, either cross multiply or multiply both sides by y plus 2, same difference. So I'll have xy plus 2x is y minus 1. You're supposed to get all the y stuff together. So subtract y over, move the not y stuff to the other side, and you sit here and go, huh, until we say the word factor. What do they have in common? Y times some stuff.
And just
Divide by stuff. The inverse function of x is negative 2x minus 1 over x minus 1. Yeah?
How'd you get the grade?
Cross multiply. Y minus 1 times 1. X times y plus 2 distribute. Okay? But once you see that, oh, you just factor the thing. We could do 100 of them now, right? It's not a big deal once you see the trick. But until you remember the trick, you're kind of in trouble. Oh, I'm not done. Not done. Domain.
Bracket -2.
Okay,
No.
look at the wording again. Does it say find the domain or state restrictions to the domain? Okay, those are different things. When I say find the domain, I'm saying give me the whole guest list. When I say state the restrictions to the domain, I'm saying who's not allowed in. Right? I don't need to say the entire negative infinity to 1. Can't touch a span, no. 1 to infinity. I can just say Caden's not allowed. He eats my goldfish.
So,
Okay? Remember that my domain and range swap. My domain here is x cannot equal negative 2. My range, if you remember how to do the rational functions.
Would the domain be x greater than?
No.
because it can be negative.
Oh, yeah.
You're thinking radicals. The degrees are the same, so my horizontal asymptote is the leading coefficients. Y cannot equal 1. So when I swap my domain and range, if my range said y can't equal 1, then on my inverse, x can't equal 1. Okay? So, basic algebra, and then, do you know how to swap your domain and range? You have 3 types, 3 different flavors. Got to catch them all. Tell me the inverse function for each of these and its restrictions to the domain. All right. Class mom, to the truck. She's not even this.
Well, did you see all those cards?
What'd you say?
Did you sign all of them?
Yeah.
You don't want to.
Subtract one. Subtract it. And then you take out one. Oh.
Let's just see 1 second. Or you can do it later too.
So you get 7 over x minus
Can I just sign some of it? Can I sign this? Yeah, did you go to, you were on the, like, 600 page. I just want to find no, it's just the beginning. Oh, it's. There's a free book. Do you want to see any of my cards I can have you? Because I'm over like senior ones and like expensive. And it's not. Yeah. So, you'll find that it's just. I was going to and I'm just like, oh, here's $1.
Both domains. Well, yeah. Information is totally.
What was the like?
Swimming?
Except it's no longer about that. I know, but I just. She never did this.
Thought she was gonna
So,
say.
I just have to like.
Yeah.
Yeah.
You did say even if it's been
Yeah.
About 12 minutes after I said it, how many of you already didn't do step 1 on part C? Check the horizontal line test. Is it even possible? Cue the erasers. Okay. Now, I could also show you that the inverse function doesn't exist by running through the full process. Remember, switch this to y, swap x's and y's. Here's a x is square root of y squared minus 20. X squared is y squared minus 20. X squared plus 20 is y squared. Look at what I'm about to do to get y by itself. Uh-huh.
plus or minus.
And because I put it in there, because I put the plus or minus there, or I put the radical there, I need a plus or minus. If I have a plus or minus radical, that means this will not pass a vertical line test. This inverse isn't a function. So I would have known that this inverse does not have a function if I had followed step 1. And at the beginning of the problem, I went and looked at my graph and saw that. It doesn't pass a horizontal line test. Since it doesn't pass a horizontal line test, I don't need to do any of this work. I go straight for the throat and say, no. Okay? How do we do on the other two?
What's the domain for the second?
Oh, not equal to 1. Remember, the original had a domain of x cannot equal 0, a range of y cannot equal 1. The original. So I swap those for my inverse. Now my domain will say not equal to 1. My range will say not equal to 0. We have to what? Maybe. It's
Just
just
type
good
in
function
that.
analysis.
And then see if it cuts off something.
But
Like
the nice part of finding the range of an inverse is just the domain of the original. Okay. So I would like you to, sounds like we did a gotcha over there. Go to the next page, the thumbs page. I want you to look at those 4. Don't do them, just look at them. Do you feel confident that you could find the inverse of each of these? Are any of them a little sketchy?
Maybe number 7. Well, I agree.
Put number 7 in your calculator. Look at it. Step 1. Does the original pass a horizontal line test? It's the butt crack graph. Okay. No, it does not pass a horizontal line test. Looks like pressed ham, right? So, because that does not pass a horizontal line test, that means that I don't have to even do the inverse. I would just say inverse function of x does not exist. Okay. Are we cool with 6 now? Having seen the thing? Okay. All right. I said the closer we get to trig and calculus, you're going to start doing more and more proof. I think I'd said this weekend I ran into a former student who's currently at Mines, and he just kind of laughed and said, yeah, you were right. After a certain point, we're not even doing math anymore. We're just proving math. Yeah. And the baby steps to that are things like, can you show me, can you prove that these two are actually inverses? Now, the way to do that, how do I know something's an inverse?
Or I guess that's just for
Everyone look straight forward. Turn your head 90 degrees to the right, 90 degrees to the left. Wow. Especially if you were in my room last semester. You've seen this before. 90 to the right, 90 to the left.
so it just
You're right back where you started. You're not all the way to the left. Okay? If something is an inverse, think of inverse operations. Add 90, subtract 90. Back where you started. Times 5, divide by 5. Back where you started. If these are really inverses, my input should be my output. Do a composition with these and show me that my input is the output. Show me that I get the identity. The purpose of f is to take 6 divided by a thing minus 4. That thing, g of x, is 6 over x plus 4. And someone starts kind of freaking out like, compound fractions, oh no. Take 4 minus 4. Dividing by fractions is easy as pie.
The second one.
Okay? The input is the output. If I say, what is fog of 100? 100. I get right back where I started. Prove it the other way. Say g of a thing is 6 over a thing plus 4. That thing is now f of x, which is the fraction 6 over x minus 4. And we say, oh no, there's compound fraction again. Dividing by fractions is easy as pie. Flip the second, multiply. That's 6 times x minus 4 over 6. And lo and behold, 6x minus 4 plus 4.
So it doesn't matter which one you plug it, like which order you
You're supposed to do both.
or both ways.
To prove that something is inverse, you do its composition in both directions, f of g and g of f. If both of them end up the identity, which they should, then you know you're right. Now we got to be careful though. Yeah, that I do the thing and I get the identity. Yay. So what happens when I say f of g of 9?
You plug 9 into one gate or into G.
Put 9 in here. I get 9. Okay? And like, so what's the big deal? What if I do f of g of 0? Theoretically, because they're inverses, input is output. I should get 0.
Don't. It's
But
not.
because I'm not allowed to put 0 into g, this is still does not exist. No solution. So, yes, they are inverses. I can prove they're inverses, but they can still have restrictions. You can have inverse functions that still have holes in their domain. So just be careful about that. That's a trap they like on ACT, is they'll talk about inverses and they'll say, what is f of the function of the inverse function of x? And they'll say, what is Fothy 5? Theoretically, it should be 5. But are you checking the domain of the inverse to make sure it's even legal? Okay, so that's a gotcha moment. That's the difference between the kid who got a 25 and the kid who got a 29. Okay, you got to watch out for those. All right, you got some functions. Show me that they are inverses. They are. I'll just straight up tell you that. They are inverses. But you got to prove it. No, you cannot cheat and just say f of g is x. Look, I did it. You have to have the work to back it up. You got to prove it. Okay, now the work isn't difficult, but you still have to show it. And this is the beginnings of algebraic proof. What are you watching? What are you watching?
Delta Rune.
I don't know that. Okay.
It's like Undertale.
I don't know that.
These are very heavy nerd topics. There's a
Okay.
I'm surprised they don't know these. Because when Delta Rune came out, it was all over the Discord server.
I remember memes. I didn't care because I didn't understand them. Okay, f of g, g of f. First one, Disturbert. I get 18 minus 18 plus x. Cool. Next one, Disturbert, or reduce. Get 6 minus 6 plus x.
What happened to, oh, you distributed
Well, right, 6. So minus 6, negative x, so plus x. Okay. Or think of it as distributed in negative 1/3. That's how I did it. So, contestant 2 says f thing, its purpose is to square thing plus 10. F of x is x squared plus 10. G of x is square root of x minus 10. Its purpose is to poke. Its purpose is to do the square root of thing minus 10. There we go. Whenever I square a square root, I get to the radicand, x minus 10 plus 10. Inside the radicand, 10 minus 10. Inverse operations, x again. Okay. So again, I'm showing you that they're the inverse, yes. But did y'all catch this? Why do they have that next to the parabola? Right next to g of x on 3b, I want you to write its domain and range. What's the domain and range of square root of x minus 10? Domain. X has to be greater than or equal to 10. Range. What happens when I put that 10 in? Square root of 0 is 0. So y is greater than or equal to 0.
The range is the domain.
The range of 1 is the domain of its inverse. They had to put that restriction there because if they didn't, they wouldn't be inverses. And we saw that on the very first slide of 1.7 when you had a parabola and then the parabola turned sideways. It wasn't an inverse function. So you will see this restriction next to them sometimes because that's the only way they will be inverse. It's the only way it'll work. So we end it there. Tomorrow we finish the last little bit of 1.7, just like today. It's pretty quick. And we will go straight into 1.2. If there's anyone who knows that they're going to be gone tomorrow, top right corner of the shelves, grab yourselves a chapter 2 packet. Yeah. We're just going to keep going.
I thought you said 1, 2.
I might have. Words are hard. And again, a reminder today, Spartan time. If you are missing a test and you have not talked to me about it, today is the day to get it done. Unless you have had a conversation with me, tomorrow lunch is your last opportunity to turn stuff in for the midterm.